All right, the chain rule, perhaps the most important rule for taking derivatives that we have. It tells us how to differentiate complicated functions, and we can just peel off the layers like an onion. And we'll see what we mean here in a minute. But first, let's just make sure that the chain rule doesn't give us anything surprising. So let's differentiate this function f of x in two different ways. First, without the chain rule. So we'll have to use a bunch of algebra and then differentiate. And then we'll come in with the heavy machinery and use the chain rule. So without the chain rule, we are going to differentiate this. Let me zoom in. We're going to differentiate 5x plus 2 cubed. So if I don't have the chain rule, I have no idea how to deal with this situation, right? I know how to differentiate x to some power, but this is not just x. This is 5x plus 2 being cubed. So if I don't have the chain rule, I just need to figure out what 5x plus 2 cubed is. 5x plus 2 times 5x plus 2 times 5x plus 2. All right, this is already exhausting. Let's leave this 5x plus 2 alone and figure out what's inside this parentheses. So this 5x plus 2 times that 5x plus 2 is going to give me a 25x squared plus 10x plus another 10x. So that's plus 20x and then plus 4. All right. Now let's perform this multiplication. So let's send the 5 through this parentheses, or sorry, the 5x. So when the 5x comes through, you get 125x cubed from that term. You get a plus 100x squared. All right, the middle term, 5x times the 20x gave us a 100x squared, and then the 5x times the 4 gives us a 20x, and now let's send the 2 through. So plus 2 times 25, that's plus 50x squared plus 40x plus 8. All right, let's again, I mean, we could differentiate at this point, but why differentiate two squares when you could combine them first? Right, how many x squareds do we have? In fact, let's order them. We've got 125x cubed. How many x squareds? We've got 100 plus 50 of them, plus 150x squared. And then 20x plus another 40x gives us a total of 60x's, and we have a plus 8. Now we are finally in a position where we can use the power rule to differentiate. So when we differentiate this, we get 3 times 125. What's that going to give me? 375 x squared plus, when the 2 comes down, hits the 150, you have a 300x plus a 60. All right, so that's your derivative. Now let's do the exact same thing, except here we'll use the tool of the chain rule. So we will differentiate the same function, 5x plus 2 being cubed. And I'll differentiate this. So I'll differentiate it with the chain rule, but I'll just do it 2 different times. The technique is the same thing effectively. They're just 2 different ways to think about it. Or rather, one kind of just dives into the details a little bit more. So let's dive into the details. I'm going to call this y. So I'm going to let y be 5x plus 2. So then that allows me to write this as the derivative of y cubed, right? Because I replaced that 5x plus 2, that parentheses, with a y. And the chain rule tells me that I can differentiate y cubed with respect to y first, and then I can differentiate y with respect to x. This is the beauty behind Leibniz notation. Your dy's sort of cancel, and you're left with the derivative of y cubed with respect to x, which that's exactly what you wanted. Derivative of y cubed with respect to x. So let me clean this up a little bit. I'm going to write down the exact same thing. So I can differentiate y cubed with respect to y, and then multiply by the derivative of y with respect to x. Now, why did we do this? Because what is the derivative of y cubed with respect to y? That's a power rule. That is 3y squared. What is the derivative of y with respect to x? Well, y is equal to 5x plus 2. So the derivative of y with respect to x is 5. By the power rule, the derivative of 5x plus 2 is equal to 5. So we're done differentiating, right? We don't have any derivatives anymore. Let's just go back and tell ourselves what y was. Right? What was y? Y was 5x plus 2. So we can clean this up a little bit. 3 times 5 is 15. 5x plus 2 squared. Now, that looks a little bit different than what we got when we first did it. But that's just because you need to expand. If you wrote 15 times 5x plus 2 times 5x plus 2, you'd end up with exactly the same thing. Now, we just went through the details of the chain rule, and very often you're not going to want to create this substitution that we just did, right, where you create a whole new variable. You're just going to be able to do that in your head. And here's what I mean by that. Oh, let's leave that alone. Let's show ourselves what we got. We got 15 times 5x plus 2 squared, right? That was the derivative that we got. All right. So when we differentiate in practice, we're not going to go through that variable substitution. We're just going to do it in our head. We're going to look at that 5x plus 2. It's being cubed, and we're just going to kind of ignore it. Right? Put your hand over, and what is the derivative of that being cubed? Well, it's 3 times that squared, right? Just by the power rule. So I kind of think of this as just something, and it's being cubed. So what's the derivative of something being cubed? You bring the 3 down, you have that something, it's being squared. Right, so the 3's down, we have that something, it's being squared. But now we actually have to multiply by the derivative of that something. So what is the derivative of 5x plus 2? It's 5. You see, it's the exact same thing that we did, except you don't actually have to explicitly write down let u be 5x plus 2. You can think of it as an onion, right? 5x plus 2 being cubed, you've got something being cubed, and then you deal with the derivative of the something.